And in this video, we're going to write formulas for ionic compounds and for acids. Note that this will be quite different from what we did with the covalent compounds. In the covalent compounds, we figured out what each symbol was, what the name of it was, and then how many there were. In the ionic compounds and acids, we do not tell you the number of each particle, but you will know how to find it by using the charges that are present. So just note that this is quite different from the covalent compounds.
These are the general rules for writing the formulas for ionic compounds and acids. Step 1, you're going to classify, make sure that it isn't a covalent compound. Everything else will be following the same system. Step 2, you're going to write the cation or hydrogen symbol first. Just write whichever symbol you have. If it's a polyatomic ion, you'll put that in parentheses. Next, you'll write the anion symbol or formula. Again, if it's a polyatomic ion, you'll put it in parentheses, making sure to have the charge on both the cation and the anion. Now, you're going to write the correct subscript that balances out the charges, and this is probably the hardest part of this. And the final step is to clean up the formula. That means that you should erase the charges that you originally had written there and any extra parentheses, the parentheses that are not needed because the group has only one of that group. I'll explain more as we continue on in this set. So here's a quick reminder. For naming the ions, remember the monoatomic ions are the cations. We have two possibilities. They can be monoatomic and have only one possible charge, or they can be monoatomic and have two possible charges. Now the ones with two possible charges you must indicate with Roman numerals, or the charge will be indicated by the Roman numeral, and so that has to be present. Our third option is that we have a polyatomic cation, and that is ammonium. That's the only one that we have. Next we have the anions, and the anions, again, are always going to end with "ide" if they're monoatomic. Then we have the list of polyatomic ions, and you'll be needing to have those memorized in order to do this set of problems. So let's review writing formulas. Once you've written the symbol or formula for each of the ions, including the charge and putting parentheses around polyatomic ions, then you're going to choose the subscripts for those ions. How you're going to choose the subscript is you're going to make sure that the overall charge of the molecule is 0. Remember that we're going to be placing subscripts on there, and those subscripts are multipliers. They are multiplying the charge and everything that's inside of the parentheses if it's a group. And in the end, we need the charges to cancel out. So if I have a +2, I have to have a +2. I need to have a -2 on the anion side. If I have a -3, those two don't match. So what I'll need to do is multiply the cation by 3 and the anion by 2, and that'll get them to balance out. So it's really important that we get those charges balanced so that at the end we have a neutral substance. All of our compounds in the end will be neutral. The tricky thing with acids is that we assume that it has a charge even though it is a molecular substance. We're going to treat it like it's charged, with the acid, the hydrogen, being a +1 charge. So that'll help you to know how to do that. We're going to think of the H+ ion instead of just being H in the molecular compound. When we're balancing out those charges, you need to make sure that those subscripts are in the lowest common denominator form. What that means is I shouldn't have a 10 and a 20 in the formula. That would be a 1 and a 2 instead. So always double check that your formula has the lowest common denominator, not some large multiple. And finally, you're going to rewrite the formula without showing the charges and without showing the extra parentheses. So how do I know when to get rid of the parentheses? The parentheses are not allowed to be there if there's only one of the group. If there's more than one of a group, then you need to have the parentheses. Remember, parentheses are only found on polyatomic ions, not the monoatomic ions, but the polyatomics where there's more than one of the whole group. Also recall that we never write 1 into our formulas. So we're going to be writing the formula for each of these, and the very first step is always to classify the compound. So we want to find out which type they are, which means we're going to find out is it ionic or molecular, And then we want to find out what classification it is. Again, this is just for extra practice on classifying. For the most part, you need to recall that we're only doing the ionic compounds and the acids for this. So let's start with looking at how we do that. The first thing you should do is to find out, is it ionic or molecular? In order to do that, you look at the first element. In this case, we have sodium. And since we have sodium, we know that's a metal. If it's a metal, it's an ionic compound. The two choices for ionic compounds are either base or salt. Bases end with hydroxide, salts end with any other anion. And so we see here that we do not have hydroxide, so this one must be a salt. Letter B, we start with aluminum, which is a metal, so this is ionic. It ends with nitride, which is not hydroxide, and so this is another salt. Why don't you go ahead and try the rest of these? Please pause the video while you try them. All right, look at letter C. We have ammonium sulfate. Starting with ammonium. Ammonium is not a metal, but it is our only polyatomic cation, and that tells us that this is an ionic compound. It does not end with hydroxide, so this is a salt. The next one that we have is calcium phosphate. Calcium is a metal, and so that makes this an ionic compound, and it does not end with hydroxide, so it is a salt. Next, we have iron 3 bromide. Iron is a metal, so we know it's ionic substance. The classification is salt because it is not a hydroxide. And letter F, we have hydrogen sulfide. Starts with hydrogen. That is a molecular compound. That's our first molecular one. But it is an acid because it starts with hydrogen. And finally, letter G, magnesium hydroxide. Starts with magnesium, which is a metal. So this is an ionic compound, and the two choices for ionic compounds are base or salt. It's a base if it ends with hydroxide, and here we see hydroxide, so this is a base. Let's go on to write those formulas. We've already classified these compounds as either acids or ionic compounds that are either bases or salts. The next step is to write the symbol or formula for each of the ions. Now in this case, I did separate these so that all of these are going to be symbols on this page. On the next page, we're going to do the ones with the formulas with the polyatomic ions. So all of these, we're going to write the correct symbol for the provided ions. Go ahead and pause the video while you do that, and then come back to me and I'll show you the answers to that. Okay, you should have found Na plus for sodium and Cl minus for chloride. For aluminum, you should have Al3 plus, and for nitride, you should have N3 minus. Remember, when the ionic substance ends with "ide," that's telling us that it is the anion and that it has no oxygens present. So nitride is just N, and we look on the column, we see that it should have a 3 negative charge. Letter E has iron 3 bromide. Now iron 3 is telling us that the charge on the iron is a 3 plus. So we're going to write that, Fe3 plus, and then bromide is Br minus. And finally, hydrogen sulfide, we have H plus for the hydrogen, and sulfide is S2 minus. And now the more challenging part. We need to balance those charges out. So in this case, sodium has a +1, chloride has a -1. They're already balanced, so the formula is complete. We just need to erase those charges. So the answer will be NaCl. You try this for letter B. And again, in this one, we see the aluminum has a 3 plus, the nitride has a 3 minus. Those two are equivalent to each other. All we need to do at this point is erase the charges, and we have the right answer, AlN. So those two are fairly simple. That is not what we commonly see. In letter E, we see a little bit more complicated one. We have iron with a 3 plus charge, and bromide has a -1.
Notice that in this model I have aluminum as my cutout. This calls for iron 3, but they both have a 3 plus charge. So I'm just going to go ahead and edit it so that it says iron where I need it to be iron.
So for this to match up, we need to add 3 bromines in. Right, so we need to add 3 bromines so that it equals the 3 plus charges. We have 3 minus charges. And the way that we write that is we have Fe, there's only one of those, and then we write Br subscript 3 because there are 3 of the bromides. In lab, we're going to have you balance out these charges with some cutouts so that you can see how the pluses and the minuses have to match up so that we get a complete square. And this is how you would see it. So for the iron 3, it'll have an Fe with 3 kind of points out. That's showing us that it has those 3 positive charges. And then on the bromide, it's going to have a negative charge that's going to go pointing in. And so we're going to put those together, and we're going to need 1 bromide for each of those positive charges. And that helps you to balance them out. Another way that you can do this, because on the test you won't necessarily have those cutouts, is to just write pluses and minuses inside of a box. That's the way I prefer to do it on a test. So let me give you an example of that. For the iron 3, I'm going to put 1 large box. It's going to have 3 plus signs inside of it. That's to say that the iron has a 3 plus charge. Then I'm going to make a smaller box for bromide, and it's going to have just 1 negative charge. And you can see that those don't line up, so the plus does not equal the minus. So I need to write another box with another bromide in it, and another box with another bromide with a negative charge in it. So that gives me a total of 3 of those and 1 of the Fe, and so our answer will be FeBr3. And let's look at our last one, which is hydrogen sulfide. For hydrogen sulfide, we're going to assume the hydrogen has a +1 charge, even though it should be uncharged because it is a molecular substance. To write out the correct formula, the easiest way to do it is to assume the hydrogen has a +1 charge. So we're going to write +1 for hydrogen, and sulfide has a 2 negative. See if you can balance that out. How many hydrogens do you need? That's correct. You should have 2 hydrogens and 1 sulfide, so our formula will be H2S. Remember, we erase all charges at the end. So those are the easier ones. Let's try some that are a little bit harder. As we did before, we already identified that these are not covalent compounds, but they are either acids or ionic, being bases or salts. So we don't need to go through that step again, but we do need to start by writing the symbols or formulas for each of the following ions. So go ahead and write the 2 parts. You'll see we have ammonium and sulfate. Write each of the ions as you know them, including the charge. Put parentheses around each of the ions, but put the charge on the outside of the parentheses because we need to use those charges to help us balance out the formula. Go ahead and do that for these 3, and then pause the video and come back to me when you're done. All right, let's look at ammonium sulfate. Ammonium is NH4. Go ahead and put that part in parentheses, put the plus on the outside. And then sulfate is SO4. Put that in parentheses, put the 2 negative on the outside. Then we look at letter D. We have calcium. It is not a polyatomic ion, so we're just going to write Ca2+, no parentheses. And then we have phosphate, which is PO4. That's a group, so we put parentheses around it. And then in this case, we're going to have a 3 negative charge. And next, we're going to look at magnesium hydroxide. Magnesium has, again, not a polyatomic, so it's just Mg2+. And then we have hydroxide, and hydroxide is OH. That's a group, so we put parentheses around it, and then we put a negative charge on the outside. And just like we did on the previous page, we're going to balance those charges. If you like using the cutouts, go ahead and do that, or if you like using the boxes, go ahead and do that. So we're going to use ammonium. It has a single point out, or if I do it in a box, it's going to be a box with a +1 charge in it. And then we're going to have sulfate, which is going to have 2 points, and we're going to see that the sulfate has 2 negative charges if we put it in the box. And so what we should see is that we need 2 of the ammoniums to match the 1 sulfate. So far we should have ammonium, subscript 2, sulfate, subscript 1. We never write the 1 subscript, and when the group has only 1, we need to erase the parentheses. If there's more than 1 of a group, we keep the parentheses, but if there's only 1 of a group, then we must erase the parentheses. So our answer will be parentheses, NH4, close parentheses, subscript 2, because we have 2 ammoniums, and then SO4, and that's it. Why don't you go ahead and try calcium phosphate and magnesium hydroxide. Pause the video and then come back to me. So the calcium phosphate is a little more challenging. As you can see, the numbers don't work out quite as easily. So calcium has a 2+, the phosphate has a 3-. If we use the cutouts, you'll see that calcium has 2 points, phosphate has 3 places to put those points. We put them together and we're left with an extra place on the phosphate. So we put another calcium in, but now we have an extra positive charge, so we need to put another phosphate in. And now we put another calcium and those two balance out. So in the end, we have 3 calciums and only 2 phosphates. Again, if you want to do it with boxes, you'll do it like this. You'll have one box with 2 pluses, and the other box, which will be a little bit bigger, will have 3 minuses on it. Then you put another box with 2 pluses. You see that they don't line up, so you put another box with 3 minuses. And finally, you put one more box with the 2 pluses in, and you can see that we have 3 of the cations and 2 of the anions. And so now, what you're going to do is see that you have a Ca, it's going to have a subscript 3, and then the phosphate is going to have a, in parentheses, because it's a polyatomic, so we're going to put in parentheses PO4, then a subscript 2. And our last one is magnesium hydroxide. And we're going to start with magnesium has a 2+. If you like the cutouts, go ahead and use those. So it's going to have 2 pointed ones. And then we're going to have hydroxide, which is a group, which has just 1 negative charge. So you can see that we need 2 of those hydroxides. What I see most commonly done with this one is that people write MgOH2. And if you read that carefully, it tells me that they have 1 Mg, 1 O, and 2 H's. What was forgotten is the parentheses. Make sure you put parentheses around the OH. A lot of people don't realize that it is a polyatomic because it doesn't have any subscript numbers, but it is still a polyatomic, 1 O and 1 H. That means 2 atoms, and that makes it a polyatomic. So the actual answer should be Mg parentheses OH close parentheses subscript 2. I'm going to add a few more to your notes. These ones are just to kind of give you a feeling for how to do some more complicated ones, and to remind you of why we need to make sure that we have the lowest common denominator. So let's step away from the notes for a moment and talk about something called the crossing method. This is a method that's used to find the correct formula for ionic compounds. A lot of people like this method. I just like to show you that it works really well. It's very simple, but there are a few times where it makes errors, so let's talk about those too. So what is the crossing method? Well, the crossing method of writing formulas says that the charge on the cation should be the number of the anion that you will have, and the charge on the anion will be the number of the cation that you have. So we're crossing those numbers so that we get the correct formula. So here we can see for sodium chloride, we get a 1 over here and a 1 over here. Of course, we don't write those ones, but we get the formula NaCl. And now we'll show you the first error that occurs, and that is, let's try aluminum nitride that we saw earlier. So aluminum, we put the 3+ here, and N has a 3-. The 3 from aluminum goes to the bottom of the N, the 3 from the nitride goes to the bottom of the aluminum. And you will see that the formula is Al3N3, and that is not correct. It looks right, but we notice that you can divide both parts by the number 3, and the answer should actually be ALN. Yet still, the method works fairly easily. You don't have to draw anything, and you can see that you just have to make sure that you have the lowest common denominator. Let's try the rest of these. Go ahead and pause the video while you try them. So just as before, we always want to make sure we classify first, and yes, this one is ionic and as salt. And then we look to see what the ions are, and we have ammonium, which we're going to put in parentheses with a plus on the outside, and carbonate, and that's going to be the formula CO3 with a 2 negative on the outside. So now you'll notice that the ammonium has a +1. That +1 goes to the bottom of the carbonate, and the -2 that we see on the carbonate goes to the lower part of the ammonium. We put just a 2, and you will see that our answer is parentheses with NH4 inside, subscript 2, and then we would say parentheses carbonate, CO3, with a subscript 1. Now notice that that 1 is a 1. We have to erase that because we don't want to keep that there. And that's it. That one worked out fine. Let's try aluminum bisulfite. Again, we classify. We know that it's ionic. We notice that it's a salt. We see that it starts with aluminum, which is a 3+, and then we get bisulfite, which is the formula HSO3 with the charge -1 on the outside of the parentheses. And now let's put that together. The 3+ charge on the aluminum goes to the outside of the parentheses for the bisulfite. And the -1 charge, we're going to put a 1 for the aluminum. And our answer then will be Al1, of course we don't write the 1, parentheses HSO3, close parentheses, subscript 3. And that one is correct. Let's try antimony 5 phosphate. Again, we see it's an ionic compound. That is a salt. And we'll write the charges. And antimony is a 5+, as it says in its name. Phosphate is, in parentheses, PO4. And then the charge on the outside of the parentheses will be -3. We'll take the 5 from the antimony, put it below the phosphate, and put the 3 from the phosphate and put it down below on the antimony. And we see that our formula is SB subscript 3, parentheses, PO4, close the parentheses, 5. And that one is correct. Now let's try tin 4 sulfide. So the tin obviously has a 4+ charge, so SN4+. The sulfide is S with a 2- charge. Using the crossing method, we see the 4+ from the tin goes to the bottom of the sulfide, and we see the 2- from the sulfide goes to the bottom of the tin. And we get our answer of SN subscript 2, S subscript 4. Did you notice that these have a multiple of 2? Hopefully you did, and you corrected the formula to SN S2. Let's try the rest of these. Go ahead and pause the video while you try them. So just as before, we always want to make sure we classify first. And yes, this one is ionic and as salt. And then we look to see what the ions are. And we have ammonium, which we're going to put in parentheses with a plus on the outside, and carbonate. And that's going to be the formula CO3 with a 2- on the outside. So now you'll notice that the ammonium has a +1. That +1 goes to the bottom of the carbonate. And the -2 that we see on the carbonate goes to the lower part of the ammonium. We put just a 2, and you will see that our answer is parentheses with NH4 inside, subscript 2, and then we would say parentheses carbonate, CO3, with a subscript 1. Now notice that that 1 is a 1. We have to erase that because we don't want to keep that there. And that's it. That one worked out fine. Let's try aluminum bisulfite. Again, we classify. We know that it's ionic. We notice that it's a salt. We see that it starts with aluminum, which is a 3+, and then we get bisulfite, which is the formula HSO3 with the charge -1 on the outside of the parentheses. And now let's put that together. The 3+ charge on the aluminum goes to the outside of the parentheses for the bisulfite. And the -1 charge, we're going to put a 1 for the aluminum. And our answer then will be Al1, of course we don't write the 1, parentheses HSO3, close parentheses, subscript 3. And that one is correct. Let's try antimony 5 phosphate. Again, we see it's an ionic compound. That is a salt. And we'll write the charges. And antimony is a 5+, as it says in its name. Phosphate is, in parentheses, PO4. And then the charge on the outside of the parentheses will be -3. We'll take the 5 from the antimony, put it below the phosphate, and put the 3 from the phosphate and put it down below on the antimony. And we see that our formula is SB subscript 3, parentheses, PO4, close the parentheses, 5. And that one is correct. Now let's try tin 4 sulfide. So the tin obviously has a 4+ charge, so SN4+. The sulfide is S with a 2- charge. Using the crossing method, we see the 4 plus from the tin goes to the bottom of the sulfide, and we see the 2 minus from the sulfide goes to the bottom of the tin. And we get our answer of SN subscript 2, S subscript 4. Did you notice that these have a multiple of 2? Hopefully you did, and you corrected the formula to SN S2. Finally, I like to talk about these two because they're a little bit more difficult. Go ahead and try them using the crossing method or whichever method you prefer. Just pause that video till you're done. Right, let's start with mercury 1 chloride. So we know this is an ionic compound, and we know it's a salt. Mercury has a 1 charge, it says, but remember mercury is kind of the weird one. We're going to put Hg, it's going to have a 2 plus and a 2 down below to give it mercury 1. That's one of those oddball ones. This is a polyatomic, even though we called it monoatomic. This is a polyatomic because there are 2 atoms, so we're going to go ahead and put that mercury with the 2 inside of the parentheses and the 2 plus on the outside. And then we have chloride, which is Cl minus. No parentheses because it is a monoatomic ion. Okay, now using the crossing method, we'll put that 2 plus from the mercury onto the chloride and the 1 minus onto the mercury 1. When we have a 1 on the outside of parentheses, we don't write the parentheses, so we write our formula as Hg subscript 2 Cl subscript 2. Could this be divided by 2? Yes, it could, but the answer would then be incorrect if you did that. In this case, while it can be divided by 2, you don't want to divide it by 2 because the mercury 1 is the group which has a 2 subscript in it. So the mercury 1 is actually Hg subscript 2. That's the group. We can't change the group. So our actual answer is Hg subscript 2, Cl subscript 2. And you'll see a similar problem with silver oxalate. So let's try that. Silver, we know, has a +1 charge. Remember, this is one of the ones that has only one possible charge. So silver has a +1. And oxalate is C2O4, and that's going to go inside of parentheses with a 2 negative. So let's use the crossing method to fix that up. We'll see the +1 from silver goes to the outside of the oxalate, and the 2 from the oxalate goes to the silver, and we end up with the formula Ag subscript 2, parentheses, C2O4, close parentheses, subscript 1. We get rid of the 1 from the parentheses, and we erase the parentheses because there's only one of that, and the answer becomes Ag subscript 2, C2O4. Now that looks like it could be divided by 2, but again, this is one where we do not want to divide it by 2 because the oxalate is a group. It's C2O4. By itself, it already can be divided by 2, but we don't want to do that because it would be the wrong formula. That would become CO2, which is a whole different thing. So we want to make sure that we keep it as is in its formula. You cannot divide it by 2. So again, those two are kind of the ones that are a little bit tricky for most people. Mercury 1 and oxalate happen to do this a lot.